Well, hi everyone. Thanks so much for showing up for Math Learning. It's Mr. Jennings. We have warmed up. We have factored the following. Somebody take me through your approach for factoring this where A is 1. What's your first step? Sydney.
I find all the factors of 40.
Okay, cool. So we're interested in that like multiply to 40. And so what are our factors of 40? 1 times 40. 2 times 20, we've got 4 times 10, and we're looking for a pair of factors that do something special. They should have a difference of 3, because I know one of them is positive, one of them is negative, because we're interested in negative 40. Aha! There they are. 8 and 5 differ by 3. And then we say, okay, well, if the 8 were negative, and we had minus 3 down here, okay? If the 8 were negative and the 5 were positive, that would give us this expression here, right? That would be x minus 8 multiplied by x plus 5. And then we check it very quickly. You can do this mental math or you can do this on your page. I encourage you to start doing it mental math, because it's a great way to build those muscles so that you can start doing things very quickly in your head. X times x is x squared. X times 5 is 5x. Minus 8 times x is minus 8x. And together those ones make minus 3x. Cool. And then minus 8 times 5 is indeed 40. So that's kind of what it looks like on my mental whiteboard when I do this check. I'm just checking each term. I'm building so many muscles when I check. So I really want you to do this. Some of the muscles you're building are, you're recognizing the form of these trinomials. The x part times the x part gives you the x squared part. That's the quadratic part. That's the part that makes this thing bend like a parabola. And then the minus 3x in there, that's the linear part. It kind of changes the angle of everything. And then the minus 40 just moves it up or down, in this case way down. Now, this one, I think you'll agree, is a little more challenging. So what's your approach for 6x squared plus x minus 1? What's your first step?
Move the 6.
Sorry?
Move the 6.
So if we try and common factor out that 6, we'll end up with 6 times x squared plus x on 6 minus 1/6, which can be factored, but it's nasty. So I don't recommend that way. I would keep everything as integers. Even if I had fractions, I'd multiply up so that I get integers, and then I would factor it. But that's like a very black diamond type thing to do. Okay, so here we have a 6 that's not a common factor for the rest of the thing. So we're going to do this thing where we still set up our magic x, but we have 6 times minus 1. You're going to do 6 times this one, the a times the c, and then that's what you're wanting to multiply to. And then we have this b down here, which is just 1, and we're looking for those two numbers. You may have learned a different method for this that you like more than my method. You are encouraged to use the methods you like. My method is to notice that if I want to multiply to negative 6 and add to 1, those numbers are 3 and minus 2. Now I take these numbers, I don't directly dump them into the brackets here. I break down the middle term. So I say 6x squared is 6x squared, that's just that. But then, that x in the middle, I'm going to use these two numbers to break that plus x into plus 3x minus 2x. Notice that 3 apples minus 2 apples is the same thing as 1 apple. So I haven't changed anything, I just wrote it in a new way that allows me to use my factoring strategy. And then I get that minus 1 down there. I very quickly check my line and make sure it's equal to the line above. Yes, it's equal to the line above, 3 apples minus 2 apples. And now I get this piece that can common factor and this piece that can common factor. And I'm going to common factor both pieces independently. 6x squared plus 3x has a common factor 3x. And inside the bracket, we will have, this is 2x plus 1. Okay. Now over here, I have negative 2x minus 1. I don't like those negatives, so I'm going to factor out a minus 1. And that gives me 2x plus 1. I very quickly check this line, make sure it's equal to the line above. And when I do my distributions in, I see that it is. And now, we get this expression. 3x minus 1 has been factored out of 2x plus 1. La da da da, that's fully factored. Okay. So notice, if it was possible to use a common factoring strategy, we would have that 6 hanging out outside the brackets. I could still get that 6 outside of the brackets by now factoring out the 3 and the 2, but I'm not going to do that for the purposes of our lesson today. Okay. So now, here is another one that I want people to try on your own. So go ahead, try this one. You've got 60 seconds, and then we'll take it up together. Let's go, everyone. Let's do this one. So, in this one, I hear people saying things like, we've got to isolate x. We have to find the equation number equals x, or x equals the number. Not 2x, not 5x, not 18x, but just x equals something. So that's our goal. So have that in mind. We want x equals number. So push all your x's to one side and all your numbers to the other. I notice here I can take away 2x from both sides. That will eliminate the x's on one side. I get the new line, minus 8 is equal to 3x minus 2x. So we've already done 3 apples minus 2 apples. That's just 1 apple. And we still have plus 4 there. And then we don't want x plus 4. We don't want to know what x plus 4 is. We want to know what x is. So I notice that if I subtract 4 from both sides, I get that. I get what I've wanted all along, which is minus 12 equals x. This is what we do when we're solving linear equations. So we're finding the value for x that makes the equations true. Okay? This is what we do. There's some values that makes them true. We want to have the skill of finding those. How about here? X minus 5 times x plus 7, we know that this equals 0. What values for x make this true? This is the interactive part. Tell me, what values of x will make this statement true? I have this multiplied by this, and it equals 0. I'm multiplying two things. They're mildly complicated algebra things. They're binomials. They're a function of x, each one. But I'm still just multiplying two things. You could call x minus 5a and x plus 7 b. And we're saying AB equals 0. A times B is just two numbers. If A times B equals 0, what does that tell you about A and B? Or I should say A or B.
One of them 0.
One of them has to be 0. Could both of them be 0?
Yes.
Both of them might be 0, but definitely one of them is 0. There's no way to multiply a non-zero thing times a non-zero thing and get 0. So either A is 0 or B is 0. So we divide it up. We say, okay, maybe it's this one. Maybe x minus 5 equals 0. Or we say, okay, maybe it's this one. Maybe it's x plus 7 equals 0. We've got two scenarios here, and we need to solve for both. Now, notice we've just created two linear equations. We just solved the two linear equations. So x minus 5 equals 0. I notice that the opposite of subtraction is addition, so I add 5 to both sides. And I have x equals 5. There's one of my solutions. Over here, I notice that the opposite of addition is subtraction. So I subtract 7 from both sides, and I get x equals minus 7. So I have x equals 5 or x equals minus 7. Okay. Two solutions. Beautiful. Let's keep going. All right. So the easiest types of quadratic equations to solve, like the green circle type questions, are the ones that are already set to 0 and factored. Set to 0, you're going to hear me say that a fair bit. So if you want to be not confused, or you want to like be solid on what I'm saying, what that means is it equals 0. We don't have equals some stuff over here. We have equals 0. When things are equal to 0, we can make progress pretty straightforwardly. Okay, so over here, somebody please just tell me what values of x make this true. I hear -1 and +6. Good. You looked at this and you said, I kind of remember that I can just flip the sign of those and that'll give me the values of x. That's cool. How about this one over here? Oh, here we've got a 2 over there. Okay, so we've got a 2 that's hanging out in front, some common factor. What are the values of x that make this one true? Over here. X is 3. And what else? -9. This 2 didn't change anything? No, it didn't. Good. Yeah. So that's another math skill. You want to be able to look at stuff like this and not be confused. That's important. Okay. And then down here, how about this one? What values for x make this true?
+3.
So 3 is good, yeah. X equals 3. But then I've got this 2x hanging out there. Up here, the 2 hanging out there didn't make any difference. Does that 2x make a difference?
Yeah.
Is there a value for x that makes that 0?
0.
Yeah. Good. That's a tricky one to spot, okay? If x is one of your common factors and it's been pulled out there, yes, that is one of the values that will give you a 0. Okay? 2 times 0 is 0. So that's true. Yeah.
So if that like 2x isn't in like a bracket thingy, then it's just 0?
Like if I write it somewhat differently, maybe I write it this way. I'm going to go to black here. So if I write 2x in brackets this way, and then x minus 3, like that, equals 0, did those brackets change anything? No, it's the same expression. So if I had like 2x minus 1, that would be different. Because now when x is 0, that bracket would be -1. I would then need 1/2. 2 times 1/2 is 1, -1 is 0. Okay? We'll see some examples like that in a second. Okay, and then, so that is x is 3 or 0, that's good. How about here? X times 4x plus 1. Well, I'm going to do the first one. I'm going to separate that. I want that factor to be 0, and oh, that was easy. If x is 0, this whole thing is 0. But if I make a little mini equation out of this factor, 4x plus 1 equals 0, what value of x solves that equation? Go, find it. While I take a deep sip of coffee. After I'm done my deep sip of coffee, I'm going to ask you for the value of x. And I'll wait until someone tells me. I think. Four times something plus 1 equals 0. What's my something? Well, it's a little linear equation. It's buried in there. We can use inverse operations to solve linear equations. Nobody? Yeah?
-5?
If I have -5, let's check it. 4 times -5 plus 1 equals, that's going to give me -20 plus 1. That's actually going to be -19. So it won't be 0, unfortunately. But that's good. You want to try these things and check them out and see if they work. Yeah?
It's not a fraction, is it?
It sure is.
It is? Is it
Unless you wrote it as a decimal. But if you wrote it as a decimal, please warn me so I can get a bucket.
Is it a -1/4?
It's a -1/4. Here's what we do. We just do the things. Okay, we just do the inverse operations. I know the opposite of addition is subtraction, so I subtract 1 from both sides. 0 minus 1 happens to be the number minus 1. Okay, that's a 0-degree day that gets 1 degree colder. And then I happen to remember that the opposite of multiplication is division, so I just divide both sides by 4. These 4's cancel. 4 divided by 4 is 1, or 1x left over there. And then we get this equation, x equals that, -1/4. And I'm not scared. I don't like go, oh no, I better check under my bed for fractions. It's just the answer. It's just, you know, it's like 25 cents, but you owe that money, you don't get that money. You know, it's -1/4. Okay, it's just that. It's great. That, if you feed it to this equation, will give you 0. So that's another way you can test these. You just substitute that value in. 0 times 4 times 0 plus 1 is 0. 0 times 4 times a -1/4. Well, 4 times a -1/4 is -1. -1 plus 1 is 0. Yeah, it's 0. You just check them. Okay. Now, if we have stuff like this, where we have a quadratic equation and it's not in factored form yet, then you factor it first. That's what you do. You factor it, and then you do what we just did. And then you can solve these things. Somebody help me find the numbers that multiply to positive 12 and add to negative 7. Ah, got him? I thought I had him, but I was wrong. I was like so wrong.
Multiply.
Yeah.
Is it -3, -4?
Yeah. Very good. So that adds to negative 7 and multiplies to positive 12. So we have x minus 3 times x minus 4. And, oh wait, I'm trying to work on my poker face where I don't give it away when a student gives me the right answer. I don't know. Let's check it. So we do x times x is indeed x squared. X times minus 4 is minus 4x. Minus 3 times x is minus 3x. Yeah, that looks pretty good. That's minus 7x. And minus 3 times minus 4 is indeed plus 12. Check it every time it builds your muscles. Okay, so now that we know that that's the factored form of this quadratic, what values of x make this true? X equals, if you can just see it, then you just write it down. If you can't just see it, do a little equation. Maybe that one's 0. X minus 3 equals 0. I happen to know that addition is the opposite of subtraction. X equals 3. Okay. Maybe that one's 0. Okay, x is 4. All right, people are good? 3 and 4 both solve that equation. Then a cool thing you can do is like check your answer by substituting it in there. Okay, you can put in 3. All right, and that might look like, I think I have blank paper over here. Yeah, so we were x squared minus 7x plus 12. X squared minus 7x plus 12. Watch this. We thought x equals 3 and 4 would solve this quadratic, making it 0. Okay, making this equal to 0. Try it. Put it in. Okay, substitute in. Go. See if you can beat me. See if you can do it faster. Oh, Mr. Jennings ain't nothing. I can substitute into a quadratic and solve it faster than he can. Oops, 9 minus 12. 21. I'm thinking about the next number I'm going to write down, and it also happened to just be flip the digits. 9 minus 21 plus 12. Huh, that's hard, Mr. Jennings. A 9-degree day that gets 21 degrees colder. I'm going to do this addition in a different order. 9 plus 12 minus 21 equals 0. I happen to know 9 plus 12 is easier to do, so that's 21. Why can't I scroll? I am at the bottom of my page. 21 minus 21 is indeed 0. It worked. It's amazing. It's just amazing. Okay, it's cool, right? So you substitute in, you solve, you find it works, and you get a surge of dopamine. Maybe not as big as when Mario saves the princess, but it's something. And it fuels you forward in your math practice. Please, start adding these error checks. They not only save errors, but they also build your understanding of the back and forth nature of these types of things. Okay, this one here, we need to work to factor that one. So we do the work. Do the work. I'll pause. You do it. And the math is right. All right, you are the next contestant on the math is right. What do you do? The x? Okay, let me work in orange. So we got 2 times minus 3 up there, or you said minus 6. I love it. Just showing people where it comes from. And we add to minus 5. Negative 3 and negative 3, I'm afraid, don't multiply to negative 6. Sorry? Negative 3, negative 2, but that multiplies to positive 6.
Wait, so then it's negative 6 and 1.
That's it. Negative 6 times 1 multiplies to negative 6 and adds to negative 5. Yeah, it's tricky, right? So when you, but like, I would make that mistake too, okay? But when I make that mistake, I feel like the Dos Equis guy. I don't often make mistakes, but when I do, I check my work and find my mistake and eliminate my mistake, okay? All right. So I'm going to use these numbers to break apart the middle term. So I got 2x squared minus 6x plus x minus 3 equals 0. I just took the minus 5 and split it into 2 pieces. They still add up to minus 5. Now I can common factor both bits. Okay, so I take out a 2x from here and multiply that by x minus 3. And then, oh look, I already have x minus 3 there. This one's tricky. So what do I write? I'm going to factor out the number 1. It's very tricky, okay? I factor out the number 1. 1 times x minus 3. That way it looks like all the other problems I've done. Factoring out a 1 doesn't change anything. It just allows me to see that I have one copy of that thing there. Okay? And now I take that apart. So I have 2x plus 1. The leftovers multiplied by the common binomial factor. This is my factored form. Now, maybe I have an appetite to check my work in Desmos. Okay? So I go to Desmos here, and I'm just going to set this where I can see my equation. 2x squared minus 5x minus 3, because of course I have Desmos on my phone, so I can do this. And then I write in the factored form that we found, 2x plus 1 multiplied by x minus 3. And then look at this. Look, watch this beautiful thing that happens when I toggle this on and off. Oh, they're the same! They're the same thing. So if you're ever doing algebra and you're wondering, like, how can I check my work? Throw both things in Desmos and see if they're congruent, if they map on top of one another. They're 99.9% yes, you're right, okay? It's very rare that they're going to map on top of one another and they're not the same thing. It's like hard to do. Okay, so next, another thing that this can do, oh, look at that, there's our answers. There they are. That's when the function is equal to 0. You see? It's crossing the x-axis. The y value is 0. So x is negative a half or 3. Let's go verify. We're going to work this one in blue. 2x plus 1 is equal to 0. I add 1 to both sides. Sorry, subtract 1 from both sides, and I get 2x equals negative 1. And then I divide both sides by 2. There it is, negative 1/2. That was one of our solutions on Desmos. And then x minus 3, yeah, that's x equals 3. Okay. Yay! How about this one? It's tricky, but it's easy. Sometimes the easy ones, you want to get these points, okay? Because they're easy, but they're tricky, so not everyone's going to get them. How do I factor n squared minus 8n? What's the first type of factoring I always look for? Do you have it? I could, but what am I multiplying to? I'm looking for two numbers that multiply to 0 and add to negative 8. It's kind of weird. I just common factor here. Always common factor first. So open your ears, sort of create a Imagine that you have a garden implement, like a hoe, that you can open a space in your mind for the words that I'm about to plant. Always common factor first. Feel the seed go into your mind, and now cover the dirt over that seed and let it grow fruit for the test on Friday. I promise you I'll give you points if you remember to always common factor first. I promise you'll like it in future math classes, and it improves your arithmetic. What's our common factor here? N squared minus 8n. N is the common factor, so this is n times n minus 8. So what are the values of n that make it true? 0 and 8, good. N equals 0 or 8. Beautiful. That's it, that's all. It's very easy, but very tricky, I think you'll agree. But it's not tricky if you know to always common factor first. Always common factor first. If we have a quadratic equation and it's not set to 0, this is kind of like getting into black diamond territory. I can mix up some black diamond questions here for sure. So if you're aiming for some black diamond on the quiz on Friday, you want this skill. You first set it to 0. What does that mean, Mr. Jennings, setting my quadratic to 0? Do I just, instead of 5, have 0? No. You subtract 5 from both sides. Now we get this new quadratic, okay? We're going to get this new quadratic, x squared minus 8x plus 12 equals 0. Now we factor it. Okay? We didn't change the equation really, we just moved the information around a bit. Now we have a quadratic that factors. This factors into, it is x minus 2 times x minus 6. There, that's how it factors. Weird. And then I say, well, x is 2 or x is 6. And then I could, if I want, substitute those in here and check them. See if this will then equal 5. You'll find it does, and it's amazing. Try these questions. I said we will discuss 6 and 7 at the end of class. No, we won't. We will discuss them tomorrow. So make sure that you try questions 6 and 7. If you get stuck there, that's why I'm here. But I want you stuck first so that that beautiful ground in your brain is like open and it's ready to receive knowledge seeds. Go.